Everybody, welcome to laboratory number 7. This is our first lab of the second semester for chemistry. Now for this one we get to study gas laws, and this one comes in 3 parts. So our first part here, we need a balloon. Now you've got balloons in your laboratory supplies. So you're going to take out one of the balloons, blow it up about that much, a little bit bigger than your fit, just like that. Don't try to blow it up all the way, just blow it up to kind of a medium-sized balloon. Then you're going to take a metric measuring tape. If you don't have a metric measuring tape, then you can use one that has inches, but you're going to have to convert it to centimeters. Remember, there's 2.54 centimeters per inch. You're going to wrap it around approximately the center of the balloon. Just get close. It doesn't matter if you're exact, just somewhere close to the middle of the balloon. Then you're going to take a marker and put marks around the center of the balloon so that you know where you measured. That way, when you measure in the future, you know where to come back to. Now we measure this, we find that this one starts out at 42 degrees. Now you're going to figure that the air, if you just blew this up, the air inside the balloon is going to be the same as your body temperature, so 98.6 degrees Fahrenheit, which you can then convert to Celsius, and then convert that to Kelvin. So, and if you want to know how to convert it, it is in your lab book. It is in your lab book. The conversion is degrees Celsius is 5/9 the degrees Fahrenheit minus 32. So you take 98.6, subtract 32 degrees from it, and then multiply by 5/9. That'll give you Fahrenheit. That'll give you, change your Fahrenheit to Celsius. And then to get Celsius to Kelvin, you just add 273 degrees to it. Now, there we've got our measurements. We've got 42 around. Now we're going to take, and I've got a pitcher of water here that is very hot water from the tap. So let your tap run until it gets really hot. Get some water. Put that water in a bowl. You're going to take your thermometer. Your thermometer is in this little cardboard tube. Put your thermometer inside the water so that you get a good measure of what the temperature is. Then put the balloon down inside the water. Now be careful, because even though it's tap water, it's still going to be hot. So just hold it here for 10 minutes. So I'll see you, or 5 minutes, sorry. See you back in about 5 minutes then. Ciao guys, back in a minute. Alright, there goes our bell. It's been 5 minutes. We can take a look at this. We see that our water, from this case, is sitting at 60 degrees Fahrenheit, so pretty warm there. 60 degrees Fahrenheit, and we're going to take and we're going to dry off our balloon. And very quickly, because this will start cooling off as soon as you pull it out, put your tape right around the same markings and measure the balloon. Oh, we see that now the balloon has gone from 42 to 43 centimeters. So we've gained 1 centimeter of space because we heated the balloon. So that covers part 1. Make sure that you measure your circumference before you heat it, after you heat it, and get the temperature of the water. There's the part 1. We'll see you back here for part 2, and we're going to get chilly for that. Welcome to part 2 of our experiment. For part 2, we're going to be testing how cold affects our balloon. So we're going to blow up another balloon. So we've got another balloon blown up. You've got your line drawn around it. You've measured the circumference of your balloon. So that's your first step. Then we're going to put this in the freezer for half an hour. So we're going to set this balloon in the freezer for half an hour. Set your thermometer in the freezer with it. That way you can get an accurate measure of how cold the balloon is when it comes out. Now remember, when you pull this out after half an hour, you're going to have to measure it pretty quick because it's going to start warming up as soon as it comes out. So I'm going to go put this in the freezer. We'll see you back in half an hour. Time to go to the freezer now, guys. Bye. Okay, we're back from the freezer now, and we can see that the freezer was negative 15 degrees Celsius. Boy, that was chilly. Alright, quickly now, before this balloon starts to heat up, we're going to measure it again. And we see that, we lost 2 centimeters while being in the freezer. Now, don't you wish you could lose 2 centimeters in certain places by just sitting in the freezer for a while? 2 centimeters from our balloon for half an hour in the freezer. There we go. Ooh. Now, for this one, you're going to need some data. So we've got your data table right here in your lab book. Just make sure you got your lab book there. You need it for the instructions. Your data table is in your lab book. You've got all the things you figured out. You've got your starting temperature being 98.6 degrees Fahrenheit, because that's what the temperature was when it came out of your lungs. Then you're going to convert that to Celsius, convert that to Kelvin. Then you're going to get your circumference of the balloon, which is what we measured. You're going to get the volume of the balloon, and I'll show you how to do the volume in just a second. The directions are in your book, but I'll show you how to do it too. Then you're going to get the refrigerated temperature of your balloon, the circumference of the balloon after it came out, and the volume of the balloon, which is calculated the same way you did the volume of the balloon to begin with. So, all of that's right there. I'll show you how to do that now. First thing you have to do is you have to find the radius. To calculate the radius, you take the circumference that you measured and you divide it by 2 pi. Remember, pi is 3.14. So it's circumference divided by 2 pi. Now, after you have the radius, then you calculate the volume. To get the volume, you take the radius that you just calculated and you cube it. Remember, cubing is multiplying it by itself 3 times. So you cube the radius, multiply that times pi, and then multiply that by 4/3. That will give you the volume. So the volume is equal to 4/3 pi times your radius cubed.